Okay, so these are all tech-free. So a function defined by the rule is sketch the graph over the maximal node, clearly labeling the axes, intercepts, etc. Don't forget, I always like to write natural log. Take that negative sign out, and that makes it a positive x and a minus 5 plus 1. So that means that my graph reflected about the y-axis, because the negative inside, 5 units to the right, 1 unit up. So as a log, I'm going to get a reflection, so I might bring my asymptote in through here. So what does it mean? My asymptote would normally be at the line x equal to 0, but it's going 5 units right. So I'm going to bring that there so we can get it. Okay, asymptote at 1, 2, 3, 1, 2, 3, 4, 5. Vertical asymptote clearly labelled, x is equal to 5. My point, which would normally be at, well, the reflection is going to take my graph. Originally, it would have been like that. Yeah. Okay, with the reflection, and then we're going to go 5 units across and 1 unit up. So if I go 5 units across, this intercept here is going to go across to 1, 2, 3, 4. 1, 2, 3, 4. So 5 spaces across, so it goes to 4 and 1 unit up. So that's where that point there is going to end up. So in reality, our graph is going to approach the asymptote, and I probably should work out my y-intercept first. And we're going to have to find both of them anyway. So at x equal to 0, y will equal natural log of 5 minus 0 plus 1, which is natural log of 5 plus 1. So we'll get that point there. Natural log of 5 plus 1. Coordinates. So I'm going to put 0 in. And to find my x-intercept, I put y equal to 0. Let's solve 0 equal to natural log of 5 minus x plus 1. Negative 1 equals natural log of 5 minus x. The base on that natural log is e, so I get e to the minus 1 is equal to 5 minus x. X is equal to 5 minus e to the minus 1. So that's my other intercept. We're going to put the, I've got to fix up 5 minus e to the minus 1, 0. And I shouldn't do this while watching the cricket. Let's get that the right way around. And what did we say it was? We said it was natural log of 5 plus 1, so 0, natural log of 5 plus 1. So I've done 2 intercepts, sketch the graph of maximal domain, label any intersections with the axes with their exact coordinates, we've done that. Any asymptotes with their equations, x equal to 5, we've done that. Okay, find the rule for the inverse function of f inverse. So we obviously, let's just swap x and y, so I can write that as x equals natural log of 5 minus y plus 1. So I get x minus 1 equals natural log of 5 minus y. The base on that natural log is e. So I'm going to get e to the x minus 1 is equal to 5 minus y. Therefore, y is equal to 5 minus e to the x minus 1. So that's not good enough, of course. F inverse is equal to 5 minus e to the x minus 1. Doesn't hurt just to put a little box around your answer. Okay. What's question 2? For the function blur, find a rule for the inverse. So same sort of thing, isn't it? We're going to write x is equal to 3e to the 2y minus 1. So let's go x plus 1 on 3 is equal to e to the 2y. So if I take a natural log, the base of that exponential is e. So I can go log base e of x plus 1 on 3 is equal to 2y. Therefore, y is equal to a half log base e of x plus 1 on 3. So let's write our final answer as f of x. So it's f inverse is equal to 1/2 natural log x plus 1 on 3. Find the rule for the inverse. That's all it asks us for. Find the domain of the inverse function of f inverse of the function. So that's simply going to be the range of the original. So the range of the original, it's an exponential taken down 1 unit, isn't it? And so it's just going to go whoosh. So you can see the range of that is from -1 to infinity. And so that makes the domain of f inverse is from -1 to infinity. Does that seem reasonable? If I put -1 in here, I get -1 plus 1, which is 0. Natural log of 0. Natural log of 0 is undefined, isn't it? So we can't have -1, so that makes sense. We can have anything slightly bigger. All right, find the rule for the domain, rule and domain of the inverse function. So again, let's put x equal to e to the 2y minus 1. X plus 1 equals e to the 2y. The base is e. Log base e of x plus 1 equals 2y. Therefore, I'm just going to go straight to f inverse is equal to 1/2 natural log of x plus 1. The domain of the inverse is the range of the original. -1 takes my asymptote down 1 unit. So the range of this is from -1 to infinity. So the domain of f inverse is equal to -1 to infinity. On the X provided, sketch the graph of f inverse of x for its maximal domain. So that's a composite function, isn't it? And what you may or may not realize is that f of f inverse, by definition, f of f inverse of x is equal to x, okay? So I'm just sketching the line y equals x, but between -1 and infinity. So it starts here, hovo dot, and we're going to go up. X, Y. Okay, so maybe just put the line y equals x, just so it's clear. On the actually provided, sketch the graph of that. C, what's that say? Find f of -f inverse of 2x in the form. It looks messy, doesn't it? Let's give ourselves some. So what's f inverse? Well, let's the -f inverse of 2x first. So f inverse, where's f inverse? Is up there. So I've got -f inverse of 2x will equal -1/2 natural log of 2x plus 1. And then we're going to substitute that into our f function e. So therefore we get, we'll go to a different colour, f of that expression is equal to e to the 2 -1/2 natural log of 2x plus 1 e to the 2x minus 1. So let's simplify. 2 times negative a half is negative 1. And I'm going to put that negative 1 out the front of k raised my power. So I'm going to write this as e to the natural log of 2x plus 1 to the power of negative 1 minus 1. And the reason I do that is because whenever you have this expression here, e to the log base e, that's actually, they cancel each other out. That's that inverse function. Okay, so e to the log base e of whatever you've got in here, I'm going to call it f of x, is just equal to f of x. So this expression here is going to give me 2x plus 1 to the power of minus 1, which is from there, minus 1. So I get 1 over 2x plus 1 minus 1. So I've got to put it in that form. So to add numbers together, I've got to get the common denominator. So let's write that as 1 over 2x plus 1 minus 2x plus 1 over 2x plus 1. So that will give me 1 minus 2x minus 1. So 1 minus 1 is 0. So I'm going to get negative 2x over 2x plus 1, which hopefully, it looks like it fits the format, doesn't it? So there we go. Solve the equations, blah, blah, blah. Okay, so they're all log base e. Again, before we can do any solving, let's get that number out the front. So let's write that as, I'm going to put natural log. Natural log of x squared minus natural log of x plus 3 equals natural log of a half. So let's concentrate on the left-hand side. If we subtract, we divide. So I get x squared over x plus 3 equals natural log of a half. Now, if log base e of something has to equal log base e of something, the two somethings have to be the same. So we don't cancel, we equate. That means x squared plus over x plus 3 is equal to a half. Let's take that x plus 3 across and bring the 2 on the left-hand side. So let's bring the 2, what happened there? Bring the 2 to the left-hand side and leave the 1 on the right-hand side. So that means I get 2x squared minus x minus 3 is equal to 0. I'm hoping this factorizes nicely for us. And if we put that as a 1 and that as a 3, and make that one negative, I get 2x times 1, which is 2x. X times negative 3 is negative 3x. Add them together, minus x, which is right. So therefore, I get 2x minus 3, x plus 1 is equal to 0. Therefore, we get x is equal to positive 3 on 2 or negative 1. Now again, check. Natural log x can't be negative 1. Okay, so in this instance, that's not a valid solution. X equals 3 on 2. We'll square around that. What have we got? Yeah, looks very similar, doesn't it? In fact, that's not even one that's in the notes. Let's have a look. Let's have a look. So again, all log base e, so we can join them together. Let's go natural log of x plus 2 squared minus natural log of x equals natural log of 2x plus 1. Subtract log, so I get natural log of 2 squared over x equals natural log of 2x plus 1. So again, we equate. So I get x plus 2 squared on x equals 2x plus 1. So I'm going to multiply that x across and expand the bracket. So I'm going to get x squared plus 4x plus 4 has to equal 2x squared plus x. So I'm multiplying this x across here into that term. I'm going to take everything onto this side, so I get a positive x squared. So I'm going to get 0 is equal to 2x squared minus x squared is x squared. X minus 4x is minus 3x minus 4. And we're going to get 0 is equal to x minus 4, x plus 1. Therefore, x is equal to 4 or negative 1. But again, negative 1 doesn't satisfy because of that log x. So therefore, we get x is equal to 4 is my solution. Solve the equation. Okay, looks very similar, doesn't it? So let's go log base 3 of 5 squared minus log base 3 of 2 plus log base 3 of x is equal to 2. So the left-hand side becomes 5 squared. Log base 3, we get 5 squared, which is 25, minus log base 3 on 2, which is divided, plus the x, so it becomes multiplied, equals 2. Now, we can't just cancel the log off. The base of the log is 3, so I can say 3 to the power of 2 is equal to 25x on 2. 3 squared is 9, so 9 times 2 equals 25x. 18 equals 25x, so x has to equal 18 on 25. Solve the equation. So there's my exponentials, I think. So let's have a look. Yes. So what have we got here? 3 to the minus 4x is equal to 3 squared to the power of 6 minus x, which say 3 to the minus 4x is equal to 3, 2 6s are 12, times 3 to the negative 2x. So what if I just multiply both sides by 3 to the minus 2x? So then I get 3 to the minus 4x times 3 to the minus 2x equals 3 to the 12. So if we multiply bases, we add the indices. I get 3 to the negative 6x equals 3 to the 12. So since the bases are the same, the powers need to be the same. Negative 6x equals 12, therefore x equals minus 2. We can check that one because, they seemed a little bit funny, so let's check. So if x is equal to negative 2, the left-hand side is 3 to the negative 4 times negative 2 is 8, and that has to equal 9 to the power of 6 minus 9, so 6 minus minus 2 is 8. So that can't be right. We've made a mistake somewhere, haven't we? So it's a good thing we check that. So instead of rubbing it out, let's try and find the error we've made. A little mistake there, isn't it? Look, there's my 3 to the minus 2x multiplying. So I said, let's bring that minus 2x across. So we should have divided or multiplied by positive 2x, because then 3 to the minus 2x times 3 to the 2x will give you 3 to the 0. So let's make that a plus x there. Negative 4x plus 2x is minus 2x. So we get negative 2x is equal to 12. X is equal to negative 6. So if x is equal to negative 6, a quick check. I'll get 3 to the negative 6, 24, has to equal 6 minus 6, 9 to the 12, which is going to be right, isn't it? Because 3 squared times 12. So that's a better answer. That's why we check our answers when we do them. Solve the equation. Well, let's just get the bases the same, which in reality we probably should have done on the previous one and just left it. 8 is equal to 2 cubed to the 2 minus x, and now straight away the bases are the same, so the indices have to equal, 3x minus 2 has to equal 6 minus 3x. Take 3x over, so I get 6x, takes the 2 across, is equal to 8. 8 on 6, which is equal to 4 on 3. Quick check, 4 on 3 is 12 on 3, which is 4. 4 minus 2 is 2. 2 minus 4 on 3 is 8 to the power of 2/3, which is the cube root of 8, which is 2. 2 squared is 4, which is the same. So that's good. What have we got? A couple more. All right, so let's get, what if we get the logs on the same side? Natural log of x minus natural log of x to the half is equal to 3. Yeah, because the square root of x is x to the power of a half. If we subtract logs of the same base, we divide. So that means the natural log of x over x to the half is equal to 3. And x over x to the half is x to the 1 over x to the half is just x to the half is equal to 3. So that means that log base e to the power of 3 is equal to x to the half. So if we square both sides, I'm going to get e to the 6 is equal to x. Okay. Solve, blah, blah, blah. Same sort of thing. So let's go. Log base 2 of 6 minus x over 4 minus x is equal to 2. So the base is 2. So I get, if you like, that 2 there, which is the base, to the power of the other 2 is equal to 6 minus x over 4 minus x. Bring that 4 minus x across, so we get 4 times 4 minus x. 6 minus x, 4x equals 6 minus x. Take the 6, so we'll get 10. 4x comes across, equal to 3x. So x is equal to 10 on 3. 10 on 3 looks okay there. So let's assume we didn't make any errors. Okay. So this one, let's just get the 3e to the t equals 5 plus e to the minus t. Now, believe it or not, this is actually a quadratic expression. To make it more obvious, what if we just multiply everything by e to the t? That way that gets rid of this negative e to the minus t. Okay, so if I multiply everything by e to the t, I get 3e to the 2t is equal to 5e to the t plus 8. 3e to the 2t minus 5e to the t minus 8 will equal to 0. So this is where you may not realise, but if u is equal to e to the t, u squared is just e to the 2t. So that's actually a quadratic kind of expression. We should be familiar with that now. So let's just write 3u squared minus 5u minus 8 equal to 0. Let's hope for a little bit of cross magic here. 8 and 1, I reckon, will work for us. and we want the 8 to be negative. So if I just do my cross, 3u times 1 is 3u, u times negative 8 is minus 8u, add them together I get minus 5u, which is my middle term. So I get 3u minus 8 equal to 0. Oh, hang on, let's take it back a step. I get 3u minus 8u plus 1 equal to 0. U equals 8 on 3 or negative 1. No reason why we can't have negative answers in there. So both answers are valid. Done.